Hello everyone, welcome to the channel Code Like Him. Guys, if you find this video helpful, please like this video and subscribe to the channel. Now let's see the second problem of weekly contest 497. So you are given a positive integer array of sides of length 3. Determined if there exists a triangle with positive area whose three side lines are given by the elements of sides. If such a triangle exists, return an array of three floating point numbers representing the internal angles in degrees. This is important, sorted in non-decreasing order, otherwise return an empty array. The answer within 10 to the power minus 5 of the actual answer will be accepted. So in the question we are giving the three sides, which will be the lengths of the three sides of a triangle if it is possible. So if it is possible to make the triangle with these sides, we need to return the angle in degrees in a sorted order. So first of all, the question arises, when can we form a triangle? So if the sum of any two sides of the triangle of the given array is greater than to the third side, then we can form a triangle. So what we are going to do, we are going to sort the array, and we are going to check if the sum of the first two sides, because in the sorted order this is only the edge case we need to check, because the first side plus the second side is less than equal to the third side. If it is if it is it's a condition, then we're gonna return this empty array because we cannot form the triangle with these sides. And now the question arises how we can find the angles of the triangle. So this is a fairly mathematical problem. So there is a cosine law. What it says that for a side C, if we can find the side C if we have this equation like a square plus b square minus 2ab cos of this is gamma. So gamma is here. So this law can be used. This law is used to establish the relation between the sides and the angle between these the sides. So what we can do is, for example, let's see this equation here. So the C is the angle opposite to the side C. So if we transfer this 2 minus 2ab cos C here and take C here, so we will get the equation that 2ab cos C equals to a square plus b square minus c square. And if we transfer that 2ab also in the denominator, we will get the cos C equals to a square plus b square minus c square divided by 2ab. So what we are so this we will find the cos C. And to find the angle C, what we can do is we can just take the cos of inverse of the whole equation. So that's what we are going to do here is we will be taking the sides as a b c. We are going to double it, a square plus a square b square and c square, and the angle A will be we are going to cos inverse of b square plus c square minus a square divided by 2bc. Similarly for b, the cos inverse of a square plus c square minus b square divided by 2 into ac, and cos the c angle will be cos inverse of a square plus b square minus c square divided by 2ab. So that's how we're gonna find the angle A, B and C. But these angles will be in radian because cos C returns the answer in the radians, angle in radians, and we know that the pi equals to 180 degrees. If we convert pi radians equals to 180 degree, so the A radian will be 180 into A divided by pi. So this is a constant in C++, which will be equal to 3.14, something like that, the whole value. So the A, B and C degree will be 180 into the angle A in radian divided by the pi value. So we are going to push into the this result and then sort it, because we need to return a sorted order, and then we can return this rest. So the time complexity will be big of one because we are not using any loop, anything else, and the space complexity will also be this one. What we can say, it's a constant because rest is only of 3 of size. So guys, if you find this video helpful, please like this video and subscribe to the channel. Thank you.